So let's take a look at example 2. Example 2 says solve this system of equations graphically. All right. Well, that means you need to rearrange both of those equations for y so that you can put them into your calculator to find the points of intersection. That's it. So I'd like everybody to rearrange the first equation for y. First equation being what I'm going to highlight in yellow. As soon as my computer catches up. It's a pretty easy equation to rearrange for y. Simply move the y to the right-hand side where you'll have x plus 1 left on the left-hand side, and you're done. Rearranging the second equation for y, which I'm going to highlight in green. Problems here. What's going on? All right. Also a pretty easy equation to rearrange for y. The y is by itself. If we can get rid of the x squared, the negative 6x and the 3. So let's just subtract those to the other side where they all switch signs. Are we in agreement on these two rearrangements? Nothing really taxing there. So now you have to put them into your calculator for y1 and y2 and find out where the points of intersection are. Zoom 6 is always the way to go. I made a mistake here. The mistake I made is I didn't check to see if I entered everything correctly before I hit graph. And I do think that's a mistake. And I didn't. By the way, I didn't know I didn't. I honestly didn't check. Jackpot. There we go. Oh. We even lucked out because the 2 points of intersection are very visible. Now, remember when I told you that you go to your calculate menu and choose intersect, I said just hit enter 3 times. The only thing to note here is that since there's 2 points, when I hit enter 3 times, it's going to find the point of intersection closest to wherever the cursor was. That's all. So 1, 2. And when I repeat the procedure, I choose intersect, I just want to scroll so that my cursor is closer to the next one. It's always going to look, I think what your calculator does is it starts looking in that vicinity and working its way out. And as soon as it finds one, it zeroes in on it. 4, 5. I don't think we need to check it. Verifying it is there. We've verified it. It's on the same, the point is on both lines. If you wanted to verify it, here's what you would have to do. Put 1 in for x here, and you'll have 1 plus 1. Put 2 in for y. You get a true statement. Put 1 in for x in the second equation. If you get 2, then 1, 2 is a solution to the system, and you will. Then you repeat it with 4, 5. Does anybody have any questions with how you would verify it if you wanted to? Okay. All right. Piece of cake. Example 3. Solve this system. So you have to rearrange both of those equations for y. And quite frankly, I hope you're in agreement. Both of these equations being rearranged for y is very easy. The first equation will be y equals negative 2x squared. Boy, I better not screw this up after saying how easy it is. Minus 16x minus 26. The second equation rearranged for y would be y equals x squared plus 8x plus 19. Are we in agreement there? The first equation, I simply moved everything but the y to the other side. The second equation, I moved the y to the other side. Negative 2x squared minus 16x minus 26. X squared plus 8x plus 19. Double check everything. Zoom 6. Again, you can see the points of intersection. Negative 3 comma 4. And guess I'm going to have to move further to this side now. Negative 5 comma 4. Those are our two solutions. Any questions with example 3? Pretty straightforward, I think. Example 4. The difference of two positive numbers is 30. And then when the square of the smaller is added to 3 times itself, you get 138 more than the larger. We got to decipher that and put that into an equation. The nice thing about this, everybody, is since we're dealing with systems of equations, we don't come up with a single equation just with one variable. We can use two variables. So the difference between the numbers is 30. I don't want to get into an in-depth explanation of something right now, but I will tell you that I would avoid using x and y when you set up these word problems. I will explain how come in a minute. Okay? So I'm just using a and b. By the way, if a minus b is 30, a is the larger, isn't it? The bigger minus the smaller gives you 30. B is the smaller. So I know I've explained this to you before somewhere else, but when you write an English sentence in math, certain words are written with certain mathematical symbols. So the square of the smaller is added to three times itself. The result, and this is a very important word in math, the result is, didn't want to use that color. The result is means equals. 138 more than the larger. Sorry, I got to use the pink one. And I'll rewrite that so we don't have to endure the colors. The second equation is 3b plus b squared equals 138 plus a. Now I'm going to ask you an important question. You have to rearrange these for a variable so you can put them into your graphing calculator, right? You need to rearrange for y. What are you going to rearrange for? Are you going to rearrange for b or are you going to rearrange for a? A. Because you can't rearrange this equation for b, can you? Our quadratic equations are always y equals, and then there's x squared and x. And this is why I said don't choose x and y to begin with, because would you agree that you could have, please don't write this down, but somebody could read this question and say, well, x minus y equals 30, and 3y plus y squared equals 138 plus x. You could do that. But then you're looking at the second equation going, oh no, now what? Am I going to plot x on the vertical axis? It causes all kinds of problems. So we're going to plot these. The first equation is a minus b equals 30, which means I rearrange for a and get that. The second equation, I can rearrange for a by subtracting 138. And I would probably say to you that you know, everybody, how frustrating it can be to get the right zoom settings. This will be the point in time where many of you would much rather solve this question algebraically. And we will learn that tomorrow. Let me put these in. Y is equal to x plus 30 or 30 plus x. So first of all, that's a line with a y-intercept of 30. If I were to go zoom standard, I'm probably not even going to see that line. This is 10. It's way up here. That's where that line of x plus 30 is, which you should know, but we'll get back to that in a bit. And then I also want to enter and I need some help here. X squared plus 30x, no, plus 3x minus 138. I mean, I know the y-intercept of that quadratic function of that parabola is negative 138. It's going to be something that's not visible. Oh, something appeared there. I'm guessing that this parabola looks something like that. And I think my only real hope here, unless I want to complete the square and start looking at x-intercepts, is to go zoom out. I think this is our best hope. Make sure I entered that correctly. Yep. Zoom out. We don't often use it because it's not a very valuable thing. Oh, there's a line. Okay, we're getting somewhere. Oh, we're getting somewhere. I can't quite see that other point of intersection, so I'm going to increase my y in the window setting to, say, 50. And the word I would describe to find the solutions graphically sometimes like this is clunky. It's clunky. It's not a very efficient, streamlined process. So let's see, intersect. Let's go to the right first. 12, 42. So what does this mean? It means the two numbers could be 12 and 42. I just want to pause for a second. You can use your calculator for this. Is the difference between these numbers 30? Good. If I take the square of the smaller and add it to 3 times the smaller, will I get 138 more than the larger? So if I take the square of the smaller, that's 144, I add 3 times the smaller, 144 plus 12 is 154. Is that, did I do that right? No, 3 times. There we go. So 12 squared plus 3 times 12 is 144 plus 36, which is 180. Okay. Is 180, 138 more than 42? Yes. Or negative 14 and 16. Do they have a difference of 30? Yes. 16 minus negative 14 is 30. And I won't go through the calculations, but if you square the smaller, negative 14, and you add 3 times the smaller, you will get 138 more than the larger. Is there anything in the question that said the numbers are positive? There is. 2 positive numbers. Oh, well, we didn't even need to waste our time with this. This is the answer. All right, one more quick question to do. How are you doing? I'm not overloading you today? Okay, good. The last question has to do with, and I'm giving you this question because you should know these words to do well in certain areas in math. The words are cost and revenue. Don't confuse revenue in business with profit. As a business person, revenue is any money that comes into my business. That's not profit. If all the money that came into my business were profit, I would be some kind of wizard, because that would mean I'm running a business without any cost out of my pocket. So if I'm going to retire from teaching, I'm going to set up I'm going to be a hot dog vendor in Sylvan Lake. I have to buy hot dogs, I have to buy buns, I have to get a permit, and then I sell the hot dogs. All that money comes out of my pocket, and then I take some money in. When the cost that the business person pays equals the revenue, the money they bring in, that's called the break-even point. If you're running a business for the first time, in the first year, you hope to break even. If your cost equals your revenue, that's break even. What would you call this? Think about that for a second. How would you describe a situation where the cost is smaller than the revenue? Actually, no, it's a profit. This is saying your revenue is more than your cost. This is saying, this is my cost. Here is my cost. Here is my revenue. This is actually profit. And deficit or loss would be that. Okay. So what's the break-even point of this particular business? You've got a cost function. It says the cost to produce n items is that. If the function notation is bothering you, then just think of it as cost equals, okay? It's given with function notation because it's just telling you cost is a function of how many items you sell or produce. And it makes sense that if you're selling everything for $20 a pop, your revenue would be equal to 20n. And again, if the function notation bothers you, don't use it. So question A says, how many items do you have to sell to break even? Which means we have to solve this system of equations. You're going to put into your calculator y equals 20x and y equals 2500 plus 22 minus 0.15 times x times x. Watch those brackets. Double check to make sure you enter everything correctly. Now, I suspect that this is going to really be the place where some of you just kind of want to throw your hands up and go, show me how to solve it algebraically. I think. Because if I were to go graph, the likelihood that I'm going to see anything here is really small, particularly that we have this number of 2,500. But what I can do, and we've talked about this a little bit before, is I can go to my table feature of the calculator to kind of gauge where these might be getting close to each other. So I'm going to set up my table to start at 0 and go up by 5. I don't know what these items are, but let's look at multiples of 5. It's selling none and 5, etc. And make sure that you change it to automatic all down the line. So second graph gives me this. So check it out. I don't sell any items. Guess what? I lose $2,500 because I don't get any money in. These numbers are starting to get closer to each other. Y1 is my cost, Y2 is my revenue. And my revenue is slowly getting closer to my cost. We have an option here. We could continue to scroll down, or we could think a little more intelligently and change the table setup to start at like 100 and go up by, I don't know, 25. It's up to you. Oh, yeah, okay, there we go. It's negative. Oh, because I'm going in the wrong direction, I probably put, let's try that again, 100. There we go. So it's looking like somewhere around 125 to 150 items. They're kind of hovering close to each other. I shouldn't be so dismissive. I should take the time to explain this. At 125 items, the cost is bigger than the revenue. But at 150 items, the cost is smaller than the revenue. So it's somewhere between 125 and 150 items. That tells us we should be looking in our window settings up to about 150. It's going to intersect someplace in that domain of up to 150. How many of you might have just put 125 to 150? I think it's better to go to 0, but it doesn't really matter. Now, what are we going to put for y? Well, look at your tables. Your y's are hovering around 3,000. So I would say 3,200. This is one of the most frustrating things for me. I can find a good picture on my graph, but it's incredibly difficult to explain it to students how they can do it. If I had my choice, I would just solve this algebraically, but you don't know how yet. Yeah, there we go. And by the way, everybody, if in case it's not clear, this is frustrating, isn't it? Trying to find the right window settings. It's not just you, it's everybody, including me. But now I can find them, the point of intersection, that is. I didn't even bother to scroll over there. So it intersects at 135.9 comma something. So this is a little bit awkward too. What's the break-even point? Is it 135 items? Well, at 135, you're not breaking even. Is it 136? Well, at 136, you're not breaking even. But if you were given this on an exam question, it would say round to the nearest item, and you would put 136. Okay? So that's what we're going to put here. The break-even point is 136 items. For what number will there be a profit, and for what number will there be a loss? Well, a loss is less than 136, because when we looked in our table less than 136, we had more cost than revenue, and your profit is selling more than 136.